Alright, in this video we'll cover the questions from lesson 4.6 and 4.7. In 4.6 we talked about sums and difference of cubes, and so we wrote the formulas down here for these so you can kind of see how these expand out in the different forms, whether it's a sum of cubes or a difference of cubes. So on the first one, part A, we have x cubed plus 27. And so when we look at this, since it's, we can tell it's something cubed plus something cubed, then we know that we're going to be using the sum of cubes. And it's a good idea to rewrite these down so that you can have in mind what your A is and what your B is in this, right? So if I rewrite this down, right, so I have x all cubed plus 3 cubed, right? So I can see that x is going to be my A in this and 3 is going to be my B. So when I put that in here, the first parenthesis says A plus B. So in this case, I'll have x plus 3. And then in the second parenthesis, right, I have a squared. So I'm going to take the a that I had, which is x, and I'll square it. So that'll just be x squared. And then minus ab. So we're going to subtract here and then just multiply the a and b together, which would be 3x. And then the last term, we square our b, and our b is 3, so 3 squared is 9. And then there's also something that is really good to do on this, which is always use SOAP, right? So SOAP stands for same, opposite, always positive. So you can see that our signs are, the thing that most people, if they make a mistake on sum and differences of cubes, it's usually because of the signs. So we started off with a plus sign, right? So in our answer, the first sign that we have is the same. So that's that S, right? And then opposite, well, opposite of our plus sign would be our negative sign. So the O is the opposite. And then P, the AP together is always positive, which is our last sign here. So it doesn't matter if we have a negative times a negative or a positive times a positive, we'll still end up with a positive. So that's why that one's always positive. Okay, so be careful with those signs. Make sure that you're really paying close attention to those and always use SOAP. All right, so there's that one. I'm going to put part B over here. And it says 8a to the third power plus 125b to the third power. All right, so when there's two different variables here, sometimes this gets tricky for a lot of students to kind of figure through what is my A and what is my B. So again, that's why I say rewrite it so it's something all cubed plus something all cubed. All right, we're going to rewrite it in this form. Well, when I'm looking at 8, right, and really, cubing something, to undo that, I can cube root it. So if I'm thinking of what's the cubed root of 8, that's 2. And what's the cubed root of a to the third, and that's a. And that's how I can figure out what my a should be. All right, so this whole thing, this 2a, is going to be a when I put it up here in my little expanded form. All right, now let's do the other one. So if I look at 125, the cubed root of 125 is 5. Oops, let's see. And then the cubed root of b cubed is b. So my b on this is 5b. All right, and again, it's connected by addition. So again, I'm going to be using that top one, the sum of cubes, to write this out in the factored form. So in my first parenthesis, right, it says it needs to be a plus b. So that's going to be 2a plus 5b. All right, so rewriting it this way makes it a lot easier to put it in this form. And then in the second parenthesis, remember, I have my a squared, so that's telling me I'm taking that 2a, that whole thing, and squaring it. All right, then I need to subtract a times b, so subtract, and then I'm just going to put down, so I'm going to do the a part times the b part, and then the last term is the b squared. Right, so when I put that in, I'll do plus 5b, right, that whole thing squared. All right, so now I've got some simplifying that I need to do in that second set of parentheses, but the first one, let's just bring down just like it is. All right, that's great like it is there. All right, but 2a times 2a would be 4a squared, and then 2a times 5b is going to be 10ab, and then 5b times 5b will be 25b squared. And so this would be factored. And sometimes it looks like to a lot of people that this trinomial, that the second part of this, could be factored more, but it actually can't. These are always going to be prime. Okay, so like this part of it here is always prime. So if you're looking to try and factor that further, you're not going to be able to get it factored anymore. It's going to always be staying the same there. Okay. I think, and I'll leave part C and part D for you to do. Both of these are subtract ones, so you'll be using the difference of cubes, but it's still going to be the same concept of what we did there in A and B. Okay, but let's move on to 4.7. And in 4.7, it's just factoring all the different ways that you've learned about. And so just trying to, figure out what do I need to do on this when it just says factor, because sometimes that can get confusing. And I'm going to come back up to example 1 in a minute. Okay, I want to do some of these other ones first because number 1 takes a little bit of time there. But let's do example 2. So on this one, I'm looking at it and saying, well, I can see there's a greatest common factor, and that's what I always want to look for first. All right, I can see that 7 will factor out of both of these terms, but there's no x or y that's common to both of them. So 7 factors out, leaves x to the 6th plus 5. Right, when I do 35 divided by that 7, I factored out, left with 5, y squared. All right, and then that can't factor anymore, so that would be your answer for that second one down. Okay, let's look at the third one down. So again on this one, first want to look and see, is there a greatest common factor that I can take out? And looking at this, I can say, yeah, I see a 2 that will come out of everything. And also, I'm going to want to rewrite this so that my AX term is in the middle. All right, so when I have, 2 different squared things, I want those on the ends and then the combination of the terms in the middle. So let me rewrite it down that way. So if I have 2x squared, actually, let me do a different color so it doesn't blend in with that. So 2x squared minus 20ax plus 50a squared. All right, and so I said, okay, I see there's a common factor of 2, but none of the variables can be factored out. So 2, and that'll leave me with x squared minus 10ax plus 25a squared. All right, and now I need to look and see, can I factor this one further? All right, and so when I do that, all right, let's see here, if I thought to myself, okay, what times what is x squared? Well, that's x and x. What times what is 25a squared? Well, that would be 5a and 5a. But in order for them both to be negative, I would need it to be negative on both of these. Right? And so then that would be my answer. Okay, and you could write it as 2 times the quantity of x minus 5a all squared, right, since those are the same term there. Okay. And then on example 4, right, again, we're looking for our greatest common factor. So that's something you're going to want to make sure that you're always doing on these, because usually a greatest common factor, some of the things that we want to make sure that you're looking for. So if we do this one, so this, let's do 12 x squared minus 40x minus 32. Just trying to factor this. Again, I look for a greatest common factor. It looks like 4 can divide into all of these, leaving me with 3x squared minus 10x, and then minus 8. And now my leading coefficient here in this trinomial is not a 1. So this is where I have to do the a times c method, right, where I'm going to multiply my 3 and my negative 8 together and make it into a 4-term polynomial before I can factor it further. But I've got to make sure I remember this 4 that's out in front. It's easy to forget about. All right, but I'm thinking 3 times negative 8, so I'm thinking what multiplies to be negative 24 that adds to be negative 10. All right, so I've got 2 times 12, 3 times 8, 4 times 6. I also got 1 times 24, right? But it looks like 2 and 12 are the ones that I want, right? Because if I have 2 plus a negative 12, right, that's going to give me a negative 10, and 2 times negative 12 will give me a negative 24. All right, so it's 2 and negative 12 that I want. So when I write this down, that first term staying the same, but remember the second term is breaking down to be negative 12x plus 2x, and then that minus 8 stays there. All right, and now it's a 4-term polynomial, so I'm going to break it in half here so I can find the greatest common factors on this. So again, remember 4 is part of the answer. It needs to stay out here. All right, but then what do we have here? Well, it looks like 3x is the greatest common factor that can come out of that. All right, and then left is going to be x minus 4. On the second part, it looks like we can take out a 2, positive 2, leaving again x minus 4. Okay, so 4 is still on the outside. X minus 4 is my greatest common factor. So it's going to come out of both of them, and then it leaves me these leftovers of the 3x plus 2. Okay, so all of this together, remember factored form means everything's connected by multiplication, right? We've got 4 times x minus 4 times 3x plus 2. All right, so we've got 3 different factors there, and that would be my answer on that one. Okay, so now let's go back up and do that example 1, because this one, like I said, it just takes a little bit more. So I'll write it down over here because I want some more room to be able to work on this. So let's factor x to the 6th minus 64. Okay, and there's 2 different ways that you could do this. But I'm going to start off, so when I'm thinking of x to the 6th, right, that first part there. So I'm trying to think, all right, is this a difference of squares or a difference of cubes? And the answer in this one is it actually could be either, right? So I could write it down. I could write x squared all cubed, right? So it's something cubed, minus 4 cubed, right? So that's a difference of cubes. Or I could write it down as x cubed squared, right? That still gives me x to the 6th, and then minus 8 squared. All right, so I could do this with either starting point. It doesn't matter where I begin on this, because in the end I will end up being the same. Okay, so I'm going to go ahead and just use that second part here that that I just wrote down. And so if I'm writing down a difference of squares, remember that's when I have one parenthesis. Right, I got these two different parentheses here, but one's connected by plus, one's connected by minus. All right, so in the first one, it's going to be x cubed, right, plus 8, and then x cubed minus 8. All right, but then I look at each of these and I go, oh, wait a minute. These can break down further. These can factor more, because this is a sum of cubes and a difference of cubes. So I can go further on this. So with the sum of cubes, remember I want to rewrite this down as something cubed plus something cubed. All right, so it's going to be x and 2. And the same kind of thing on this. X cubed. Oh, that looks crazy. All right, so x cubed minus 2 cubed. All right, but there I have my A and my B that I just was talking about in the other section there. All right, but I have two different things that I'm dealing with here. All right, so let's start off with this first one, the x cubed plus the 2 all cubed. So if I write that in a sum of cubes form, in the first parenthesis, I'll have x plus 2, and then I need to square my first term, so x squared, then minus the two terms multiplied together, so minus 2x, and then square that last term. So 2 squared is 4, so plus 4. All right, and now let's do the other one. This is the difference of squares now. So then I'll have x minus 2 in that first parenthesis. And then I'll take my x term, square it, so x squared. And I'm going to do plus the 2 and the x multiplied together. And then square that last term, so plus 4. And again, remember those trinomials on those cannot break down any further, so I am done. That would be your answer there. Okay, and whether you started it out that first way that I wrote down or this second way, you will end up with the same answer, just a different way to get there.